Hello everyone, welcome back. It's Jessalyn, and tonight we have the sound of the rain behind us, and we also have this nice globe here, okay, which is going to help us discuss the nature of the constellations. We're going to think about how we came to know them and how we can see them. I also have a book of star maps here, which we will look through to help us figure out how we can identify different stars in the sky. Okay, so the reason I have this globe here tonight is because I want to take a look at how the axial tilt, or the direction in which the Earth points as it rotates around the sun, affects the different things we see in the sky. This axial tilt of 23.4 degrees affects what we can see, and it also affects the seasons. It's what gives us the seasons, and the seasons dictate what we can see at which time in the sky. Now, the southern hemisphere here is a much brighter place to see the stars from, because the southern hemisphere points directly towards the galactic center of the Milky Way. From the northern hemisphere, we can't see the galactic center very clearly. It rests too close to the horizon for us to view. But here, it fills up the center of the sky. So what is the galactic center of the galaxy? The galactic center is the middle, the orbital point of our galaxy. Everything is orbiting around that galactic center. And contained in the center of a galaxy is a massive black hole that is pulling everything to it. So the concentration of stars around that galactic center is going to be much higher than farther away on the outer ends of our galaxy. We are located about 2/3 out of our galaxy. So when you are in the northern hemisphere looking out, you're not looking at the center of the galaxy, but rather out into the universe at the edges of the Milky Way. That means you see a smaller concentration of stars, and you'll see stars that are not nearly as bright as you would see in the southern hemisphere. So that's something to consider, and that's a reason that I've brought us this globe to look at. So places you can see the stars in the southern hemisphere are places like Australia. That's a good place to see the stars in the southern hemisphere. You can also look in South Africa, which has many places to view the stars. Namibia as well has many places to view the stars. You can also look in South Africa in places like Costa Rica, Chile, which will give you a wonderful view of the southern hemisphere's night sky. In the northern hemisphere, the United States offers a lot of great places to view. In addition, Canada, and of course Europe will allow you to see a great deal of stars in places like Germany or the Canary Islands in Spain. Alright, so if you're interested in taking a trip to view the stars in the southern hemisphere, Australia or South Africa is a really good place to go. And in the northern, you can go to a place like Utah in the United States or California in the United States, to one of the national parks, to view a very, very clear and very bright night sky. But let's think about the history of constellations, because we know that the Greeks, if we find the Greeks on the map, and also the Arabs who are, for instance, in Iraq, Baghdad, who were charting these constellations, are of course in the northern hemisphere. they're not going to be able to see the Greeks or the Arabs of the time into the celestial southern pole. They won't be able to see any of the constellations that lie in that area. So up until about the 16th century, we only had 48 constellations mapped, both by the Greeks and the Arabs. It wasn't until the 16th century that travelers, merchants on trading trips to the East Indies began mapping stars in the southern hemisphere and putting them into constellations, named not for Greek myths, but rather the scientific equipment they used and the extraordinary sights they beheld, like the peacock is one of the southern hemisphere's constellations, taken from a trip to the East Indies. So, how our constellations came to be. Let's get to Greece on our map. And I'm sorry you can't really see it. It's very far away. You have to use your imagination. So we'll go to Greece now. Here's Greece. See Athens and Turkey across the Aegean Sea. And we have Crete down here and Italy right there. Okay. So we have Greece. Of course, so many of our constellations depict Greek myths, but a lot of these Greek constellations were adapted from ancient Babylonian constellations. They were taken and Greek myths and names were added to them. Then Ptolemy put all of these constellations in a book, and this book did not have any illustrations, so he wasn't illustrating the constellations, but rather stating the constellation and the star's location in it, essentially creating a long list of stars and constellations. Ptolemy's work fell into the hands of Abdurrahman al-Sufi, a famous Arab astronomer in Baghdad, Iraq. So if we go to Iraq, we're going a little southeast from Greece and Rome. Just above Saudi Arabia, we find ourselves in Baghdad, Iraq, with Abdurrahman al-Sufi. Now he took Ptolemy's star map, which again was not really a map, but rather a catalogue. It contained no illustrations, but a list of the different constellations and the list of the stars located in each of them. He took this and included illustrations of each constellation. Then, during the Arab invasion of Spain, these were translated into Latin. So his translation of Ptolemy's work, called the Almagest, which is an Arabic translation of the name, was given illustrations by Abdurrahman al-Sufi, and then it fell into the hands of the Europeans. Albrecht Dürer was the first to print these star charts, right? He printed the Almagest in 1515 thanks to the creation of the printing press. And these were based on a translation to Latin made in Spain after the Arab invasion of Spain. This German artist would depict the stars of two hemispheres, the 12 figures of the zodiac, visible from the northern, and then all the stars south of the zodiac. They were numbered in the order that they appeared in the Almagest, or the initial Ptolemaic log of stars. Now, this means that because you have the Arabs, the Greek, and Europeans all charting stars, that we have no stars that would be visible from the southern celestial pole. That would mean completely empty, because to the northerners it is permanently below the horizon. So essentially an entire half of the sky was completely unmapped due to this geographical reality of where this work was being performed. So that brings us to a Dutch cartographer who lived from 1552 to 1622, and his name was Petrus Plancius. He wanted to fill up that southern hemisphere, the southern celestial pole. And so he asked Peter Kaiser, the chief navigator of a 1595 Dutch trading expedition to the East Indies. He wanted them to help him chart the stars in the southern hemisphere. And so Kaiser, though he did die on that expedition, was able to chart 100 different stars and divided them into 12 new constellations, which represented what explorers saw on their mission. Some examples are constellations featuring a peacock, a flying fish, Columba, the dove, and Monoceros, the unicorn, and most importantly, probably most famous, one that we will look at when I turn the camera around, the Southern Cross. Nicolas Louis de La Salle, I always have trouble with French names, I'm so sorry, de La Salle, Lacaille. He would further define the southern hemisphere in 1750. So he went to Table Mountain in the Cape Good Hope. Okay. Cape of Good Hope, which is very, very at the bottom of South Africa. This is one of the places, if you wanted to travel to view the southern hemisphere, would be a perfect place to go. Here. So Nicolas went here, and it was there with a very rudimentary telescope. He was able to log 10,000 stars over the course of a single year. This is pretty much unheard of. And he also developed 14 new constellations based on his work down here in the southern hemisphere, which he then presented to the French Royal Academy of the Sciences in 1754. And so that added 14 more. We had 12 more added from the East Indies. And so we're taking our 48 closer to the 88 that is finally codified in international agreement in the 1920s, 1922, I believe. When we codify all of those different stars or constellations, their borders are then made more specific, and so they lose the kind of pictorial shapes that Abdurrahman al-Sufi would have illustrated, or Al-Correct Dura would have illustrated. They're no longer these artistic things, but much more scientifically determinate. So that's a shame. But we can still look up and see those initial shapes. Okay. So, let's turn the camera around now and take a look at star charts so we can see a few different constellations, both in the northern and the southern hemisphere. Okay, I'll turn it around now. Okay, so I want to begin with this illustration here of Abdalrahman al-Sufi's 964 CE depiction of Ptolemaeus's star charts, or star log, the Almagest. So you can see you have our zodiac symbols on the outer ring, and then different constellations in a jumble, because some constellations do overlap in their star stars, which became an issue in these illustrations. So you see your different zodiac symbol, Sagittarius. Now Sagittarius is important because it contains Sagittarius A, which is the black hole that is the galactic center of our universe. So when you look towards Sagittarius, that is where you're going to see that galactic center. And the black hole is Sagittarius A within it. Okay, so that's the Arabic illustration. I'll show you also this here, which is an illustration, an Arabic style illustration. Right here. So you can see the way in which it is illustrated is very different than, for instance, the illustrations we'll see from a European illustrator, which I'll show you in a moment. Let me just move this camera up so we can see a little bit better. There. Okay. Alright, so European illustration. B, for instance. Right here, a very different style. Okay. And this map is using more specific delineations between them rather than pictures. As you can see here. So we have these different pictures. But let's go now to our star charts. Okay. So we can see the different hemispheric charts here. This is what we're going to use as we look at our constellations. I am in the northern hemisphere here. Some of you, most of us are in the northern hemisphere, just based on who watches me. But there are some of us who are in the southern hemisphere, so we'll look at both. Now I'm going to have to move the camera a little bit closer now, so you can really see, because it's very, very small, the writing. So we're going to get very, very close. So you'll notice here, in your northern hemisphere, you have this red line. You see that? That red line is tracking the movement of the sun over the stars. So that is called the ecliptic line. And so the ecliptic line, again, is the movement of the sun over the stars, because of course the sun is our closest star. So it's going to be moving in front of the stars. So again, the ecliptic, the ecliptic. Now, you see on these hemispheric charts, we have the months written around. So the way you read this is you're actually going to position the month you want at the bottom of the page. So we're going to move this up so we can see the entire hemispheres chart. It's August now, but it's close to September, so we're going to move September to face us to the bottom. So we're going to see how the sky looks in September. Okay? Now when you're looking for stars or constellations and you're using a map like this, what you're going to do is, this is everything you'll see if you're looking south, due south from the northern hemisphere. So what you'll see, one that I think is most recognizable, is the Big Dipper off to the right upper hand corner of the sky. And I was out a couple days ago and I actually did see this here. So this is Virgo there. So you can see Virgo pretty clearly in September from the northern hemisphere up in that right hand corner of the sky. Now you're going to want to look for those really, really bright stars, which are shown here. A bright star from our previous video is going to have a negative magnitude. So there's actually a something here that's going to show you the larger the star is, the smaller than 0 the magnitude is. So looking for those really bright stars that even if you're in your heavily populated area, you'll be able to see them. So in September, you might look directly into the Cygnus here with this very bright star there. So we're just going to keep that in mind, that we're going to look at the Cygnus as constellation when I turn to the constellation themselves. So that's when you're going to look straight up and see that really bright star. If you move right over, you're going to see Lyra with another really bright star right there. Okay. And then Aquila. All right. Aquila has another really bright star. But also right here, you have Pegasus. So this is another important constellation, because if you find Pegasus, you can find the Andromeda galaxy. It's just going to be located right there. So with the right amount of darkness, you'll be able to actually look up at that and locate that in the sky. If you can find Pegasus with this somewhat bright star right below Cygnus. So if you can identify Cygnus here, you can then pop down to Pegasus and then find your way to the Andromeda galaxy there. Okay. So you also have Aquila right here, right? This has got a hugely bright star right there. So you're seeing these bright stars of Lyra, Cygnus, and Aquila forming a kind of triangle there. So that triangle is going to help you identify some of these different constellations. You also have, I'm going to butcher this, but I think it's Butes right here, which is going to have a really, really bright star. And that's an interesting constellation that we're going to look at. And then, of course, that is right below Virgo. So if you can find Virgo, you can find Butes, and Virgo to me is really, really easy to spot. Okay, and then let's take a look now at the different ones that I have actually described. Oh, here's Perseus there, which that Arabic illustration we were just looking at was actually an illustration of Perseus. So this here is Perseus in the sky. So again, September, this is next month. You're looking up, Perseus is going to be right to the middle left in the sky, and you can identify it by looking for that very, very bright star here, okay, of Auriga. So Auriga's bright star, if you look right below, you're going to see Pegasus. So look for these bright stars, learn where these bright stars lie, and you'll be able to figure out what kinds of constellations you're looking at. But let's just look at some descriptions of those constellations. But before we do that, I actually want to just limit page flipping here. Look at the southern constellations. So we're going to move now into the southern. Now before we do that, this cloudy area here, see that? That's the Milky Way. Now I want you to notice how the density of stars in the northern hemisphere in the Milky Way compared to the density of stars in the southern hemisphere. So I'm going to pull us in to the southern hemisphere now. Go right through. Alright, so just here. Here we are in the southern hemisphere. Right away you can see the density here in that Milky Way much higher, much higher. And so if we're going to find Sagittarius, let's find Sagittarius. Okay, this is Sagittarius here, so ideally somewhere around here is where you're going to find the galactic center of our galaxy, if you were to look up. what you're going to notice is you have a lot more globular clusters. So that's what this little yellow thing is. You probably can't see it because we're not close enough. But you have more globular clusters here in this dense area. And you also have more bright nebula. So right here you're having a bright nebula. So when you get to like the Sagittarius area, you're going to see a lot more. Okay? So that's important to note. So let's look now at September and see what we're going to see and where the location is from the southern hemisphere. So I won't be able to see this sky. Where's September? Okay, we're going to go around. Here we are, September. Okay, can we see? So September is right here. Okay, so looking up, you can see the Milky Way is right there. I mean, you can just look directly into it, and it's so bright. So you can see why the southern hemisphere has like better viewing. So let's look at some of these bright stars. Okay. So let's see. We have this one here, right at the end of the Eridanus. So if you're looking up from the September, you're looking up, you're going to see Eridanus right here. It's the very end of Eridanus. Going right across there, okay? And then we're also going to see this one. You see that one? This one is Carina. Carina has a very bright star right there. But the really important one you're going to notice, if you can see it, is right here. If you're looking up and you can identify this really bright star, which is belonging to Centaurus. So this is Centaurus here. This is a really important, very visible constellation. See that? And right inside Centaurus is like head here. You can see the legs of Centaurus and the tail there, and other legs, and this really bright star there, and another bright star. Right under is the crux, the southern cross there, and you're going to see 4 stars and a cross. So we're going to check that one out. That one's very popular constellation to look at. So we'll check that one out. There's a Virgo, so you can see that on the southern hemisphere, you're literally flipped. So while Virgo would be on the right for us in the northern hemisphere, in the southern hemisphere, Virgo is on the left, but almost in the same exact place, just flipped on its side. So that's kind of interesting to think about. And then you have Orion over here, right? Okay, you got your 3 stars of the Orion constellation. His arm and the bow right there is going to be where Virgo would be in the northern hemisphere. And so Orion for us is flipped as well. But we're not going to see Orion. Orion's a winter constellation, so you're really not going to see it in September. You kind of got to wait until October to see Orion. Okay. So these are how you read your star maps, right? You just move according to the month you want to look at, and you can literally look up. So if you have this picture, or you get yourself a picture like this, and you carry it with you, when you go outside, you'll be able to pretty easily identify your constellations based on that brightest star, with the negative magnitude reading. Okay, so let's now look at the actual descriptions of our different constellations. So I'm going to go ahead and turn this around. And let's look at some that we would see in the northern hemisphere first. We're going to go to Lyra again. Let's just look very quickly at what we're going to see. Lyra, let me find it, because we're not looking from September. We're looking from April right now. Lyra's right there. Okay? So we're going to go find Lyra in the book and learn about her. That seems like a female constellation to me. So we're going to go to 151. Okay. Okay, here's a more up-close look at Lyra. I'm sorry, that's Lynx. Here's Lyra. There she is. Okay. Gonna get nice and up close on Lyra. Get a little closer to how Lyra looks. There we go. Okay. There she is. You can see Cygnus next door, right there. Okay. So I'm just going to read to you about Lyra, the Lyre. A constellation dating from ancient times, representing the stringed instrument invented by Hermes and subsequently given by his half-brother Apollo to the great musician Orpheus. This constellation has also been visualized as an eagle or vulture. Although small, Lyra is bright and prominent. It contains the fifth brightest star in the sky, Vega, which forms one corner of the northern summer triangle. Deneb in Cygnus and Altair in Aquila mark the other two corners. Okay, so let's find Vega. Here is Vega. So when you're looking for Lyra, the brightest star you're searching for is, of course, Vega here. Now, what does Lyra actually contain? This book is really great. It will tell us, if you go over here, the different stars contained in Lyra. And so you see the alpha is Lyrae, okay, also known as Vega, the swooping eagle, okay. It's a brilliant blue-white main sequence star, 25 light years away, fifth brightest star in the sky, surrounded by a disk of dust from which planets may be forming. So if you look up at Vega in, so let's look at that. If you look up at Vega, you can imagine that that dust realm around Vega is potentially forming planets, which means Vega may have its own solar system. So Lyra may contain soon its own solar system off of the Vega star, which is pretty fascinating. Okay, so you also have Shellac, the harp, which is the beta. So the alpha is going to be the brightest, beta is going to be probably the second brightest. So let's find that. Shellac is right here. I don't know if you can see it. And you can see the sign for beta is there. Okay, so that's Lyra, the harp, or the lyre. Okay, here is Cygnus, the swan. Right, you see here? This is the constellation right there. Okay, so let me read from it. Cygnus represents a swan flying down the Milky Way. In Greek mythology, the swan was the guise in which the god of Zeus visited Leda, wife of King Tyndareus and Tyndareus of Sparta. The result of their union was Pollux, one of the heavenly twins. The flying swan's tail is marked by the star Deneb, Alpha Cygni, its beak by Alberio, Beta Cygni, and its wings by Delta and Epsilon Cygni. These stars form a distinctive cross shape, so the constellation is also referred to as the Northern Cross. It happens to be far larger than the more famous Southern Cross. Cygnus lies in a rich part of the Milky Way, which is split here by a dark lane of dust, known as the Cygnus Rift, or the Northern Coalsack. Deneb, the constellation's brightest star, forms one corner of the so-called Summer Triangle, completed by Altair and Vega. So we're in the same kind of realm. Among the fascinating objects in Cygnus is an X-ray source called Cygnus X1, thought to be a black hole orbiting a 9th magnitude blue supergiant star 6,000 light-years away. It lies near Eta Cygni at 19 hours and 58.4 minutes, 35 degrees. Near Gamma Cygni is Cygnus A, a powerful radio source caused by two distant galaxies in collision. Long exposure photographs of the region between Epsilon Cygni and the border with Vulpecula reveal beautiful swirls of gas known as the Veil Nebula, the brightest part of which, NGC 6992, is detectable in amateur instruments. So I chose this A because it has Deneb, one of the brightest stars, but also because it has that black hole and those colliding galaxies. So this Cygnus the Swan is a really, really good constellation to know, and it's a good constellation to think about if you're able to acquire a really, really strong telescope. So let's take a look. So here is Deneb right there. Okay. So Deneb here, and you can see it does form a cross, but it's also its neck and wings flying, as said. So again, Lyra is right over here, so you're literally just moving to the left and finding Deneb. And that way you can find a lot of different pretty fascinating stuff, like Cygnus X1, a black hole. Okay, so each of these constellations contains some pretty amazing astronomical features, I guess is what you could say. Especially this kind of dust called the Cygnus Rift. Okay, so that's another one. Now let's take a look at the Southern Cross. This is viewable in your southern hemisphere, right? It's one that I mentioned. So here is our Southern Cross, very small cross, much smaller than the Northern Cross we just looked at. This is Crux. Hear it right there. Now Crux is beautiful because it's in a very bright part of the sky, okay, of the Milky Way. So let's look at it for a second. Let me read to you from Crux. The smallest constellation in the sky, but one of the most celebrated and distinctive. Crux was visible from the Mediterranean area in ancient times, so its stars were known to Greek astronomers. The effects of precession have since carried it below the horizon from such northerly latitudes. The Greeks regarded it as part of Centaurus, but it was made a separate constellation by various seamen and astronomers in the 16th century. So remember I talked about the people that went on that trip to the West Indies. They were responsible for naming the Southern Cross as separate from Centaurus. Okay. It can be useful for direction finding at night, since its long axis from Gamma to Alpha Crucis points toward the South Celestial Pole. So the Southern Crux is used for navigation. Crux lies in a dense and brilliant part of the Milky Way, and the famous dark nebula known as the Coalsack is particularly striking in silhouette against the starry background. Okay, so we can see here a depiction of some of the stars present. So Crucis, this is the Alpha star, is 320 light years away. and appears to the naked eye as a bluish star of a magnitude of 0.8. But a small telescope divides it into a sparkling double with components of magnitudes 1.3 and 1.8. Okay. And then you have a bunch of other different stars that we don't really need to go into. But that is the Southern Cross. So if you're in the Southern Hemisphere in September, you can see that. And it's very bright and a very important constellation for navigation. Okay. So let's now go to Bootes, which is 107. I might be pronouncing that wrong. Apologize for that. Okay, 107. Okay. Let's go here. Bring this into view here. Here we go. Look at that. Now I brought us this so we can see Arcturus, which is this very bright star here. Okay, it looks like a kite. You can see. Alright, so let's read this. Oop, I'm making a big mess. Okay, so let's read this one now. Bootes the herdsman. Turn it this way so you can see. There. An ancient constellation representing a herdsman driving a bear, Ursa Major, around the sky. The herdsman is often depicted holding the leash of the hunting dogs, Canis venatici. The name of the constellation's brightest star, Arcturus, actually means bear keeper in Greek. In Greek mythology, Bootes represents Arcas, the son of Zeus, and the nymph Callisto. Neighboring Ursa Major represents Callisto herself, who was turned into a bear by Zeus's jealous wife, Hera. Now, the reason I also chose this constellation is because you can witness one of the year's most abundant meteor showers in this constellation. So if you can find it, you can witness this meteor shower. The let me look at this. Quadrantids, which radiates from the northern part of the constellation, an area that was once occupied by the now abandoned constellation Quadrans Moralis. Okay, so on January 3rd to 4th each year, you can watch about 100 per hour of these meteors in this specific location. So if you know about Bootes the herdsman, you remember on January 3rd and 4th, get your star map out, go to the correct month, and search for that part of the sky. You may be able to witness that faint meteor shower. So this is an important one to know, okay, if you're in the northern hemisphere. Alright, now the Andromeda is, of course, very, very important. We're going to go to 99 now and check out the Andromeda galaxy. Because you can see that. The Andromeda constellation. Oops, that was a terrible sound. So sorry. Okay, Andromeda is right here. Okay. Here we go. Okay, this is Andromeda. Alright. So Andromeda represents the daughter of Queen Cassiopeia, who is chained to a rock as a sacrifice to the sea monster Cetus until saved by Perseus, whom she subsequently married. So let's take a look at this here, so you can really see it. Okay. The constellation was one of the 48 listed by Ptolemus. Despite its fame, Andromeda isn't particularly striking, as its brightest stars are only second magnitude. Its most prominent feature is a crooked line of 4 stars extending from the Great Square of Pegasus. The most celebrated object in the constellation is the Andromeda Galaxy M31, a spiral galaxy like our own Milky Way. It is the most distant object visible to the naked eye. So, the 2 stars leading from Merak or Beta Andromedae act as a guide to it. So, this Andromeda Galaxy, visible in the Andromeda constellation, is the most distant thing that we can view with the naked eye. And so let's find these stars. Beta Andromedae. Let's see if we can find that in the picture here. I'm going to turn it on its side so we can look at it. Alright, let's find our stars. Merak here, and we're looking for Andromeda. So from Merak you can go up here, M31. This is our galaxy. So if you're finding Andromeda, you have this like kind of V shape here with this line of 3, not super bright, but still pretty bright stars. Almach, Merak, and Alpheratz. So this is the beta there, and this is the alpha there. So you could find these 4 lines, 4 line of 4 stars, and then from the 3rd star, pop over. This is Andromeda. Now you're going to have a pretty clear night in order to see Andromeda because it is super, super distant. But, you know, if you're in a good spot for viewing stars, you should be able to see this, especially if you have a telescope with you. Okay, so the Andromeda constellation again has that 1, 2, 3, 4 down the side. Okay, and so go to the 3rd and look up a little bit, and you'll find Andromeda Galaxy. Okay, now let's look at Centaurus next. So this is visible in the southern hemisphere in September. I'm going to see it. Okay, so this is a large and rich constellation representing a centaur, the mythical beast that was half man, half horse. Reputedly, Centaurus depicts the scholarly centaur Chiron, the tutor of many Greek gods and heroes, who was raised to the sky after being accidentally struck by a poisoned arrow from Hercules. Okay, so a line from Alpha to Beta Centauri points to Crux, the Southern Cross. Okay, and the closest star to the Sun, Proxima Centauri, is a red dwarf, which is viewable in Centauri. So if you wanted to know one of the closer stars to us, you can look to Centaurus to find it. So let's find that star real quick. Proxima Centauri, or Proxima Centauri, right here. Okay. So it's actually like a very, very small little star. It's not very bright at all. It's very low in brightness, but it's right there, just outside these lines of the Centaur. Okay. Now, Centaurus A, if we find that, let's find Centaurus A. Where would that be? It's going to be a galaxy, so it's NGC 5128. So this galaxy, this is Centaurus A, our galaxy here, which you can see if you're looking in Centaurus, is one of the strongest radio sources in the sky. So that's really cool. So you have that galaxy there creating the strongest radio sources in Centaurus. Now, it is in a very prominent part of the Milky Way, so it contains more naked eye stars than any other constellation. So if you're in the southern hemisphere, you see Centaurus, you're going to see an incredibly large amount of stars, okay? So that's why Centaurus is so important. But you also have that really cool galaxy there. Now let's look at maybe one more. Let's look at Eridanus, and then we'll call it a night. Eridanus is going to be an E, so let's go to E. That's enough past the E. There are a lot of ASMR videos about doing alphabetical order, so here we are. Okay, so this is Eridanus here. This is the 6th largest constellation in the sky. Again, visible in the southern hemisphere. It meanders from Taurus to Hydrus in the south, and in mythology, Eridanus was the river into which Phaethon fell after trying to drive the chariot of his father, Helios, the sun god. But it also represents a real river. Early mythologists identified it with the Nile, but later Greek writers said it was the Po in Italy. So this potentially is meant to resemble the Nile or the Po. Okay. Originally, Eridanus included the stars of what is now Fornax, and it stretched only as far as Theta Eridani, which is given the name Achernar from the Arabic meaning the river's end. So I love this one because it does have so much water imagery. And remember, I was talking about how a lot of these constellations will have Arabic names for Greek myths. Remember that actual translation is a Y. In more recent times, Eridanus has been extended to nearly 60 degrees south. Okay. So the constellation contains several interesting galaxies which are too distant to be picked up on amateur telescopes. But one of these galaxies is NGC 1300. So let's find that real quick. The galaxy is a little like circle oval thing. We want to find 1300. You'll see a lot of them. So that's a galaxy there. We also have a galaxy here, which is NGC 1291. So you have 2 galaxies here, and though they're faint, if you had a really good telescope, you could see them. Okay, because this 1300 here is about 69 million light years away, so it's pretty far. But that's your Eridanus there. Let's do one more, why not? We'll go to Carina now, or maybe Mensa. Mensa is actually kind of boring. Let's go to Carina. Mensa is fun because it was named after Table Mountain in South Africa. But let's go to Carina. Wow, look at that. Do you see how active that is? It's amazing how much the southern I have to go to like Costa Rica or something and look at this. So Carina, this constellation was originally part of the extensive Argo Navis, the ship of the Argonauts, until the figure was divided into 3 parts in 1763 by French celestial surveyor we talked about, Nicolas Louis de Lasalle. The other 2 parts are Puppis and Vela. Carina, the smallest of the 3, represents the ship's keel or hull. Okay. So Carina lies, as part of Argo Navis, Carina originated in ancient Greek times and is associated with the legend of Jason and the Argonauts and their quest for the Golden Fleece. Carina lies in the Milky Way, providing rich star fields and clusters for binoculars. The stars Iota and Epsilon Carinae together with Kappa and Delta Velorum, form a shape known as the false cross, which is sometimes confused with the real cross. So I think Carina is amazing just because of the sheer volume of open clusters that are present in it. Because again, we're looking, you can see this dusty stuff. That's to imply the Milky Way. We're looking right near that galactic center. So you're going to see all of these open clusters here, those little kind of rings. And those are going to look so cool and bright. And then you have Crux over here. That's the Southern Cross. You can see boom, 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 right? So this would be the false cross. Boom, 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 boom. But that's not the cross. And so, yeah, that's a good, nice, really bright constellation to end on. If you're in the southern hemisphere in September, you'll be able to notice Carina the Keel and see some of these amazing star clusters there. Okay, so I would suggest, let me just show you the title of this book real quick. If you're interested in this kind of thing, it has some really amazing maps. It's the Stargazer's Bible right here. It's taught me a lot, and it's excellent, so I would suggest it. But thank you so much for joining. I hope you learned a little about constellations and what you'll be able to see in September, depending what hemisphere you're in. And have a wonderful night. Goodbye, everyone.